Section 1.5, Matrices. In this section, we will define a matrix and we will perform arithmetic operations with matrices. Then we will find the sum, difference, and product of two matrices and find scalar multiples of a matrix. At this point in time, you might be wondering, what is a matrix? And just simply speaking, a matrix is a table of values. So it's a bunch of numbers written down in order, and we typically refer to the matrix by the order or the size or the dimensions of the matrix. So an example of a matrix might be like this one in the middle of the page, which consists of the numbers 1, 2, 3, 4, 5, 6. In this particular case, the rows of the matrix are 1, 2, 3, and 4, 5, 6. So there are 2 rows in this matrix. On the other hand, there are 3 columns, the column 1, 4, 2, 5, and 3, 6. So this is a matrix of size 2 times 3. So for a matrix size, we always write the number of rows first, and we follow that with the number of columns. If the numbers are identical, so like a 2 by 2 or a 3 by 3 matrix, we call that matrix a square matrix. So the size is also the order. So instead of saying size, you might be hearing me say sometimes order or the dimension of the matrix. So let's take a look at example number 1, where we have some data organized in a table, but instead we want to display it in a matrix. The table shows the number of TVs of different models sold last month at the 3 different store locations. So in part 1 of the problem, we are told to express this data in matrix forms, and this is straightforward. All we have to do is just copy the data, which consists of the numbers 206, 180, and 150, followed by 185, 201, and 180. Finally, the last numbers are 140, 160, and 250. Make sure you put some space between the numbers, and also to emphasize the fact that this is a matrix, we put a square bracket at the beginning and a square bracket at the end. In the future, we are going to be calling this by a specific name, so I can call it, for example, matrix A or matrix B or any other variable you like. In this case, I'm just going to pick the letter A, and that is my matrix, and we're done with part 1. So the next question is asking us to find the dimensions of this matrix. And to find the dimensions or the order or the size, all I have to do is count how many rows there are. So in this case, there's 1, 2, and 3 rows. So there are 3 rows. And how many columns do I have? I have 1, 2, and 3 columns as well. So this is an example of a square matrix because the size contains identical numbers. The number of rows and the number of columns is the same. Okay, so for part 3, it's asking for the entry A23 and what does it represent. So when they say A with the subindex 2, 3, they are asking me to find a specific number in this matrix. And the first number tells me what row I should look into, and the second number tells me which column I should look into. So they want me to specifically find the value that is in the second row, but also at the same time in the third column. So what value is in the second row and third column? So second row is this row, and the third column is that column, and I'm seeing the number 180. So that is the value that we call A subindex 2, 3. And what is 180? In fact, 180 is the number of TVs sold in the National City Store of the model C. So you can take a moment to write that down if you like. I'm not going to write the whole sentence down, but that's what the number represents. So again, 180 represents the number of TVs sold in the National City Store of the model C. Okay, moving on to part 4, we are asked to find the sum of the entries in row 1 of the matrix. So row 1 of the matrix is the row containing the numbers 206, 180, and 150. They want the sum, and they want me to say in a few words what this number represents. Okay, so 206 added to 180 added to 150 will be 536. And this represents the total number of TVs of model A, B, and C that were sold in the La Mesa store. So I'll repeat that one more time. The sum of the numbers in the first row of the matrix represents the total number of TVs that were sold in the La Mesa store of model A, B, and C. So regardless of the model, that's how many TVs we sold in the La Mesa store. Okay, finally for part 5, it says to find the entries in column 2 of the matrix. So column 2 of the matrix, that's basically this one. So it's the sum is going to be 180 added to 201 added to 160. Okay, that's 541. And again, they want me to write a few words explaining what this number actually means. So if we look back, the second column is what we added together. This is the number of TVs of the Model B kind that were sold in every store that we have in this problem. So La Mesa, National City, and La Jolla. So again, what does 541 represent? 541 is the sum of the numbers in the second column of the matrix. It's the number of TVs of Model B that were sold in La Mesa store, National City store, and La Jolla store. Okay, before we move on any further, let's explain what it means to say that two matrices are equal. And the definition is there in the middle of the page. It says two matrices are equal if the order is the same and the corresponding entries are equal. So what does that mean? It means that for two matrices to be the same, first of all, they have to have the same size. So if I said I have a matrix called AB, to be equal to another matrix, it just means that both of them should have the same size, in this case, 2 rows and 1 column each. And each entry has to be equal to the corresponding entry. So this top one, A, has to be equal to 1, and the bottom variable B has to be equal to the number 2. If those are all the same values, then we say that the two matrices are equal. So in other terms, I cannot say that AB is equal to another matrix like 1, 3, 2, 4. This would not be true because the size of this matrix AB is 2 by 1, and the size of this matrix is 2 by 2, so that won't work. The two matrices are not equal. Okay, so taking advantage of this definition, let's go ahead and solve example number 2, which says solve for A and B given the following matrices. So in the first problem, in part 1 of this problem, we have a matrix on the left and another matrix on the right. So this matrix on the left has 1 and 2 rows, so that's a 2 by how many columns? We have 1 column, that's the second one, and that's the third one. So this is a 2 by 3 matrix, so that's the size of that one. And on the other hand, we have another matrix here, which also has 2 rows and 3 columns, so it's a 2 by 3. So it is okay to ask if the matrices are equal. And in fact, we are told that they are equal, so all we have to do is now find A and B. A is found in this entry, and B is found in this other entry. So to find A and B, what I have to do is basically start by saying, well, let's find A. So we want to find A. And to find A, I'm going to highlight where A is located. I can see that it's in the second row, first column. So I'm going to the other matrix and I'm going to highlight the corresponding entry. So those two entries must be the same for the matrices to be equal. So in other terms, what I'm trying to say here is that A plus 1 has to be equal to 7. And clearly A has to be 6 for this to work. 6 plus 1 will be equal to 7. Now, to find B, which is the second value that's missing, I'm going to highlight where B is found. It's in the first row, but second column, and the corresponding entry would be this other one over here. So in other terms, we're saying that 3B minus 1 has to be equal to the value 2. So again, two matrices are equal if the size is the same and the corresponding entries are equal, and all we have to do now is solve for B. To solve for b, we'll move the 1 across, so that means 3b has to be equal to 3, and so therefore b has to be equal to 1. And so that's the end of part 1 of this problem. So before I give you the answer for the second one, I want you to pause the video for a moment and ask yourself, are these two matrices equal in part 2 of the problem? And can you find A and B yourself without looking at the rest of the video first? So pause the video here for a moment and I'll give the answer in a second. Okay, so hopefully you had some time to pause and to answer the question. So again, I'm seeing that we have a 2 by 2 matrix. So why is that? Well, this is a first row, and this is a second row. And at the same time, I can see that there's one column there and another column that makes it a 2 by 2 matrix. So the order is 2 by 2. And on the other hand, the second one is also one row, second row. So that's a 2-row matrix. And how many columns does it have? It has one column, and here's the second column, so it's a 2 by 2 matrix. So it is okay to set the equality, and let's go ahead and find A. So where is A at? A is in this corner, so it must be equal to that corner. So I'm trying to say 2A plus 3 has to be equal to -5. So that means that 2A has to be -5, and we're going to subtract 3 from that, so it's going to be -8. So therefore, A needs to be -4 for this to work, for the two matrices to be equal. And that's one of the two missing variables. So what we need to do next is find what B is. And again, I'm going to highlight the corner that B is in and highlight the opposite corner on the other matrix. So 2B plus 5 on one side, and it must be equal to, seems like -9 is the other entry corresponding to it. And again, to find B, I need to isolate it. So let's get rid of the 5 by subtracting both sides by 5. So that's going to give us -14. So B should be equal to -7 because we're dividing by 2 on both sides of the equation. So hopefully you got this right. And if you did, good job. If not, see me in office hours and let's try to work on this together. Okay, so next let's worry about adding and subtracting matrices. And since matrices contain numbers, usually we can add and subtract them just like we add and subtract regular numbers. But again, the first thing you have to worry about when you're adding and subtracting matrices is that the order or the size of the matrices has to be the same, and the result will be another matrix with the same order. So for example, in example 3, part 1, we're given matrix A and B, and the numbers are hidden behind these variables A, B, C, D, E, F, G, H, and we're basically being asked to find the sum of A and B. So they just want us to add A and B together. And the process of adding A and B together is very straightforward. I'm going to start by copying the matrices. So A, B, C, D is my first matrix, and I need to add it to the second matrix, E, F, G, and H. And to add the two matrices A and B, first of all, I'll have to check if the size is true on both of them. Is it identical? This matrix has size 2 by 2, and the second matrix has also size 2 by 2, so we can proceed with the addition. It is okay to add the matrices, and what we do is we add corresponding values. So A gets added with E, B gets added to F, and so on and so forth for the rest of the variables. And so my result is going to be a 2 by 2 matrix with a lot of variables in it for this case because we don't have any actual numbers. So A plus E will be the first entry, B plus F will be the second entry, C plus G is the third one, and finally D plus H. So you can think of this as the formula or the recipe to add matrices, and you can follow that in every future problem. And also notice how the result of this matrix that we just got, it's a 2 by 2 matrix. There's one column, here's a second column, and also there is 2 rows. That's the first one, and this is the second row. So if I have actual numbers, what would this look like? So I'm going to do part 2 of this problem where I'm given matrix A with 4, 1, 3, 2. and matrix B with the numbers 5, 9, 0, 7. And I'm being asked to add them up. So let's go ahead and do that. As usual, the sizes are 2 by 2 for each, so we'll add 4 and 5 with each other, we'll add 1 and 9 with each other, we'll add 3 and 0 with one another, and finally 2 and 7. And the result will be 4 plus 5 is going to be 9, 9 plus 1 is going to be 10, 3 plus 0 is 3, and 2 plus 7 is, again, 9. Okay, so that's how addition works. Subtraction is basically the same, except instead of a plus sign, you will have a minus sign instead. So let's tackle that in example number 4. So again, we're given two matrices, A and B, and this time we're asked to subtract the matrices A, B. So let's start by writing them. A, B, C, D is the first matrix, and we are subtracting E, F, G, and H this time. And again, we're going to subtract the corresponding entries from one another. So what would that look like for this particular instant? For this particular part, A minus B will be A minus E, B minus F, C minus G, and finally D minus H. Okay, and again, the final result as before, this is a matrix that contains 2 rows and 2 columns. So the size of the final answer is a 2 by 2, what we call a square matrix in math. Keep in mind we started with a 2 by 2 matrix and another 2 by 2 matrix that we subtracted. We already know this information from the previous page. So this is the order or the size or the dimension, depending on which class you're taking or who's your instructor, they might use a different word to describe this 2 by 2. Okay, so maybe it's a good idea for you to pause the video again and try to solve the next problem for part 2 before I give the final answer. So the matrix is 4, 1, 3, 2. The other matrix is 5, 9, 0, 7. Pause and see if you can find the difference A minus B. Okay, as before, you'll need to subtract the corresponding entries, and in this particular case, 4 minus 5 will be negative 1, 1 minus 9 will be negative 8, 3 minus 0 is going to be 3, and finally 2 minus 7 will be negative 5. And just a word of caution when you're writing down these matrices, try to space out the numbers so that you can have a blank space between the two of them. You don't want to write negative 1, negative 8, and then 3, negative 5 so close to one another that you start thinking that you're supposed to subtract negative 1 and negative 8. They're supposed to be like in different columns. So just a word of caution, make sure your notation is good so that you don't confuse yourself in the future when matrices get bigger and bigger and we're dealing with a lot more arithmetic in each matrix. Okay, so in example 5, the matrices that were given are 3 by 3 each. There's 3 rows and 3 columns in each of the matrices. So it is a legitimate question to ask what's the sum or what's the difference of these matrices. Remember, the sum and difference cannot be found if the order is not the same. Just like with equality, the two matrices cannot be equal if they're not the same order. So let's see if we can get A plus B. And this time I'm not going to highlight everything, just the first few numbers. So I'm adding 2 and 6 with each other. That's going to give me 8. Then I need to add the negative 10 with the 10. That should give me a 0. So let me keep those highlighted for a moment. And the next entry that we'll have to worry about is the negative 2 and the negative 2. We're adding them. So negative 2 added to another negative 2 will be negative 4. And so on and so forth. So the next entry is 14 with 0. If I add those guys, I'll end up with 14. Then I'll have to do the 12 and the negative 12. When I add them up, I get 0, and so on and so forth. So I'll continue doing the rest of this. 10 minus 4 when added will be 6. 4 when added to negative 5 will give me a negative 1. Negative 2 when added to 2 will give me a 0. And finally, 2 with the negative 2 added again will be 0 as well. And the size of the final answer is a 3 by 3 matrix as well. So just like before, the size, if you start with a 3 by 3, you should end up with a 3 by 3. If you start with a 2 by 2, you should end up with a 2 by 2, and so on and so forth. We just have to be a little bit more careful when we're doing a minus b, because we are subtracting and there's a lot of negative signs already there. So I'm supposed to subtract 2 minus 6 first, then I'm supposed to subtract negative 10 with the other negative 10, then I'm supposed to subtract negative 2 with another negative 2. So I'm putting the numbers, I'm not finding the answers yet because it's a little bit more confusing. The next one is 14, and we're subtracting 0 from that. Then we have 12, and we're subtracting a negative 12 from that. Then we have 10, we're subtracting a negative 4. And finally, the last row, 4, subtracting negative 5. And negative 2, we're subtracting a 2. Finally, we have a 2, and we're subtracting another negative 2. So again, that's the first entries, that's the second one, and so on and so forth. I'm not going to highlight all of them. It's going to become really obscure. So I'm just going to do that and move on to find the final answer. So what's my A minus B matrix? So 2 minus 6 will be negative 4. Negative 10 minus 10 is going to be negative 20. Negative 2, there's a double negative and another 2, so that's going to be negative 2 plus 2, which is going to be 0. 14 minus 0 will be 14. 12 minus 12, so that's going to be 12 plus 12, which is 24. Then 10 minus 4, that's going to be 10 plus 4, which is 14. And again, double negative, we're going to have 9. Then negative 2 is going to be negative 4. And finally, the last one is 2 minus 2, which is 2 plus 2, which is, again, 4. So that is the solution of the difference of A minus B, the matrix. So I hope that was pretty clear, pretty straightforward. As you can see, it's not very difficult. It's just a different way of doing math. It's just organizing math differently, and the operations are pretty straightforward so far. Now with scalar multiplication, what will typically happen is you'll have a number that you need to multiply to every entry of the matrix. So you'll be given some kind of matrix. It could be a 2 by 2 or any other random size. And you'll see a number written down in front of the matrix. And what that means is the number needs to go to every entry of the matrix. So we'll give it a shot here with example number 6. It says A is the matrix, which is a 2 by 2 matrix with the numbers 8, 1, 5, 4. And for part 1, we want to find the product 3 times A. There's not supposed to be the word sum right here, just the product 3A. So I'm supposed to multiply 3 with the matrix that we call A, which is 8, 1, and 5, 4. So what does that mean? That literally means we want to multiply the 3 to the 8, the 3 to the 1, the 3 to the 5, and the 3 to the 4. So 3 times 8, that's going to be 24. 3 times 1 is going to be 3. 3 times 5 is 15. And 3 times 4 is going to be 12. And that's the matrix that we call 3A. So when you multiply a number times a matrix, that's what we call in math a scalar multiplication. And we'll talk about how to multiply a matrix with another matrix later on another page. So again, this word is not supposed to be there. We want to find the product of negative 2b. So my matrix B consists of the numbers 4, 1, 3, and 2. And I want to find negative 2 times that amount. So again, the negative 2 on the outside will go to every number inside the matrix. And the result will be a negative 8 with a negative 2, then a negative 6, and a negative 4 at the end. Okay, so for the next example, part 7 or problem 7, we will combine everything we've learned so far to find the sum of the 3a plus 2b given the matrices A and B. So in this problem, the matrix A is a 3 by 3 matrix, and the matrix B is also a 3 by 3 matrix. So we are allowed to add them or subtract them or whatever. But on top of that, what we have to do is we have to give the A multiply by 3, and we have to multiply the b by 2 before we can perform the complete sum of everything. So what I'll do is I'll write down the answer to 3a first, then I'll write down the answer to 2b next. And once I have all those values, I'll go ahead and find the sum of the two of these together. So for 3a, I'm just going to do a little bit of mental math. I'm going to take every number in a and multiply it by 3. So for example, the 1 multiplied by 3 will be a 3. Then negative 2 multiplied by 3 is going to be negative 6. Then 0 is going to get multiplied by 3, still going to be 0, and so on and so forth for the rest of them. So next, 0 times 3 will be 0. Negative 1 times 3 is negative 3. 2 times 3 is 6. 4 times 3 is 12. 3 times 3 is 9. And 3 times negative 6 is negative 18. So this list of numbers represents the matrix that we call 3a. And to make sure that it's a matrix, I'll put the square brackets on the left and on the right. So this reminds everybody reading my answer that this guy is a matrix. So similarly, let's go ahead and do the product of 2b. So I'm going to take every entry inside of b and I'll write down the answer down here. So negative 2, 2 times 2 is going to be 4, 2 times 1 is going to be 2, 0 times 2 is going to be 0, negative 3 times 2 is going to be negative 6, then 4, then 0, then 2, then negative 8. So that's the product that we're calling 2b. And what we want next is to just find the sum of both of these guys with each other. So we want to add 3a and 2b. So obviously, because these matrices are originally 3 by 3, the final answer that I'll get is also going to be a 3 by 3 matrix. And so what I have to do is add this entry 3 with the entry negative 2, then negative 6 with 4, then 0 with 2, then 0 again with 0, then negative 3 with negative 6, and continue the same process over and over again. So what will I end up? For the first row, 3 minus 2 will be 1, negative 6 plus 4 will be negative 2, and 0 plus 2 is going to be 2. In the second row, 0 plus 0 will be 0, negative 3 added to negative 6 will be negative 9. Then we have to worry about the 6 and the 4. When you add them up together, that's going to be 10. And finally, 12 and 0 will be a 12. Then 9 and 2 will be 11. Then we're adding negative 18 and negative 8. That should be something like negative 26. And because it's a matrix, I'll put the square bracket and the square bracket. And this is the final answer. So I'll just box it up. And that's it. That's the end of this example. Okay, so before I continue further, let me show you how to do this with your TI calculator in case you have one, in case you want to know how to add and subtract matrices. So you can have two options. You can either add them by hand or using the calculator. So let me get the calculator going and show you how to do this. Okay, so first things first, we need to enter the matrix menu, and these steps are going to be mentioned in the video later on in written form, so you can come back to them in case you forget or in case you're not able to follow. But the matrix menu is going to be the same key as x to the negative 1 key, but you'll have to use the second button in case your calculator doesn't have a specific matrix key. So for me, I'll have to click second, then matrix, and that will get me into this matrix menu. And there are three options: names, math, and edit. So the first thing we'll do is edit the matrices. And edit just means you're going to give the calculator the numbers you're working with for your problem. So for me, I was dealing with matrices A and B, so I'm going to edit matrix A by clicking either the Enter key or 1 on my keyboard. And the first thing I got to do is tell the calculator what's the size of my matrix A. And then the last problem we just did, the matrix had a size 3 by 3. So I'm going to type 3 and hit enter, then 3 again and enter. And automatically, I'll get a matrix with all zeros on my screen. And now I'm ready to type in the numbers that were living inside of the matrix A. So in my matrix A, there was a number 1, then the number negative 2. So be careful when you're putting negative values in the calculator. You don't use the big minus sign. You need to use the little minus next to your enter key. So that tells that tells the calculator that the number is negative, not you're subtracting the two numbers. So 1 and then -2 and then 0. And as you do this, the calculator will jump from one row to the next column and to the next row and so on. And all you have to do is just type in the numbers one by one. So my next number was 0. Then the second row, second column is -1. So again, tiny minus sign. Then the number 2. Then again 4. Then 3. Then -6. Again, use the little minus sign. And when you finish typing in all the numbers, the cursor will jump back to the first spot, but we don't want to do anything anymore. So what we'll do is we'll quit this whole menu. So to quit, we're going to click second, then the mode button, and that gets us back to the main screen on the calculator. Now we have a second matrix to put in, the matrix B. So again, I need to go back and edit another matrix. So again, I click the second key, then the matrix button, which is the same as the x to the power of -1 button. And again, I'm going to use my arrows left and right to go to edit, but I want to put a new list of numbers in a different name. So I want to save them under the name B, so I can click down and click enter, or just very quickly on my keyboard, I can type in 2, and then it will take me straight to the matrix B, as you can see. And the original size is always 1 by 1, so I have to modify it and tell the calculator that my size is 3 by 3. Once I type in the 3 by 3, it populates the entries with all zeros. So I need to put in my few values next. So -1, tiny minus sign again, and then 2, then 1, followed by 0, then -3, then 2, followed by 0, then 1, then -4. And again, it's always a good idea to be super careful here. Make sure that all the minuses are tiny. Make sure you didn't copy any numbers incorrectly, because if you do, then it's kind of, that's it, like end of story. You're not going to be able to get any correct answers because you're putting in the wrong numbers to begin with. And what I'll have to do next is just leave this whole thing. So I'm going to go second, quit. Okay, so now I want to perform the addition of 3a plus 2b. So if I want, I can do it all at once, and this is how I do it. So 3, and then I need to tell the calculator to multiply the 3 with the matrix A. So I enter the matrix menu by clicking second matrix, and this time I'm not going to edit. I'm just going to click the number 1 on my keyboard, and you'll see there's a 3 bracket A bracket on my screen. So this tells the calculator I want to multiply 3 by A. If you want to stop here, you can click enter and it will give you the answer to the product of 3A, but I'm going to actually do the whole problem all at once and tell the calculator to add 2B next. So to do that, I put a plus sign, I put a 2, then enter the matrix menu and click 2 on my keyboard, and you'll see now there's a 2 bracket B close bracket. And when I click enter, I should see the numbers that we produced ourselves by hand. The numbers are 1, -2, 2, 0, -9 and 10, 12, 11, and -26. So we actually had the correct values. We got the same numbers by hand, but now you have two different ways of doing the problem. And it's a really good idea to be able to do this with a calculator, especially for the later sections. Especially on the next page, for example, when we start multiplying matrices, it is super fast and super quick to do it with a calculator, but it takes a lot longer by hand. And for you guys, you are allowed to use a calculator, so why not take advantage of it and do the problem with the calculator? So with that in mind, let's talk about multiplication of two matrices, and the product is going to be a little bit more advanced. For the product of matrices, again, we have to talk about the order first. And what do we have to say about that? Well, it turns out that to multiply two matrices, you need to have the orders kind of match in some way. So, for example, in this problem, the matrix A has a 2 by 2 size, and the matrix B has a 2 by 2 size. For the product to work, you want the middle numbers to match. If these numbers 2 and 2 don't match, then the product is not defined. So if those numbers in the middle are the same, you can do the product. If the numbers are not the same, then you just say no solution, no answer. And even if you try to do it with your calculator will say error. Now, the answer will be made up of a matrix that has this size with this size. So the answer is going to have the first value and the last value. And there's a formula written down in the middle of the page on how to do this, but I think it's best explained if I do the problem by hand and show you how it's done. So we'll talk about that here in example 8. We'll illustrate how to do the product. The other thing we have to be careful about when we're doing multiplication of matrices is that the multiplication may not be commutative. As a matter of fact, it is not most of the time commutative. So what do I mean by that? Back in the real world, if I do 2 times 3, I get 6. And if I multiply 3 times 2, I also get 6. In the matrix world, this is not always 6. So 2 by 3, a matrix multiplied by another matrix may not result in the same value or even the same answer if you do the product backwards. So if I multiply matrix A and B, sometimes I get another matrix. Sometimes if I try to do B times A, there won't be even an answer. So that's what we mean when we say that multiplication is not commutative. So let's start with example 8, which has the matrix A with the numbers 1, 2, 3, 4. This is a 2 by 2 matrix. And we're supposed to multiply with the matrix B, which is 5, 6, 7, 8. And this also happens to be a 2 by 2 matrix. So I want to know what A times B is. So you can put A times B. What would that be? Well, first of all, is it legal? Can I even do this? Checking the inside numbers, these guys are equal. So it is okay to perform the product. We will be allowed to multiply A and B. What's the answer going to be? What's the size of the answer? It's going to be a matrix with, again, a 2 by 2 order or size or dimension. Okay, so how do we multiply in reality? Well, let's write down 1, 2, 3, 4, and we want to multiply this matrix with the matrix 5, 6, 7, and 8. So we know that there's going to be 4 answers in the final solution. So there's going to be one answer that goes here, another one that goes there, another one that goes here, and finally another one that goes there. And let's search for the first answer. So how do I get the first answer? What I like to do is to take the row 1, 2, and with a little pencil, I like to write it next to the numbers 1 and 7. So I like to write the 1 and 2 from the first row next to 1 and 7, and then perform the product of these numbers. So 1 times 5 will be 5 later on, and then 2 times 7 will be 14 later on, and we'll add the 2 solutions. So that's how you get the first entry of the first row, first column. So what if I want this second entry in the first row but second column? So again, what I'll do is I'll take the first row, because I want the first row answer, and I'll take the second column, because this guy lives in the second column, and I'll multiply those guys. So I'll put 1, 2 in my pencil there, and I'll just kind of think to myself, what's 1 times 6 added to 2 times 8? That will be the entry that goes there, in that little spot. And when I'm done, I go ahead and erase everything, because we don't want to confuse ourselves later on. So suppose I want this entry over here in the second row, first column. Because it's in the second row, first column, I take the second row and first column and I multiply them. So again, with my little pencil, I write 3 and 4 next to the numbers, and I go, okay, this is going to be 3 times 5 and 4 times 7. And then when I'm done, I just go back and erase everything. Finally, if I want the entry in the second row, second column, well, because it lives in the second row, I grab the second row from the first one, first matrix. And because it's in the second column, I grab the second column from the other matrix, and I multiply them. So with my little pencil, I write 3 and 4 next to the numbers, and I'm supposed to multiply 3 times 6 and add to it 4 times 8. So that's basically how you multiply 2 matrices. I mean, we're not done completely because we have to multiply and add the numbers, but that's the first step in the process. So let's finish it up. 1 times 5 will be 5, and 2 times 7 will be 14. So 14 and 5 will be 19, and so on and so forth. So the answer will be 19, 22, 33, and 50. So you saw probably this is a lot more complicated than adding or subtracting or even multiplying with a scalar. So let's give it a shot with our calculator. Let's try to type in all these numbers into the calculator and perform the product with our TI calculator. It might be a lot faster. As a matter of fact, it is a lot faster and it's a lot easier to do it that way. So we're going to try that next. So get your calculator ready and let's type in all the numbers for A, B into the calculator and multiply the two matrices. Okay, so back on the calculator world, I need to go into the matrix menu, and previously we did another problem and there are some issues in my calculator. If you go into the matrix menu, you'll see A and B already have some numbers, 3 times 3, 3 by 3. So it already remembers the entries from the previous example, and we don't want that. So we want to remove those entries. So what I'll do is go to the edit column and I'll edit matrix 1. And this time, I'm just going to tell the calculator, hey, forget the 3 by 3 matrix. I want a 2 by 2 matrix. And instantly, it starts removing numbers. There's some leftover numbers, so what we'll do is just write on top of them. So as a matter of fact, my matrix A for this problem where we're multiplying has the numbers 1, 2, 3, 4. So I'm just going to type 1, enter, and when it jumps to the next row, next column, all I have to do is type 2 and then hit enter, and continue the same way. 3, enter, 4, enter. And you can see now the new matrix A has different values. It's 1, 2, 3, 4. Then we'll quit. Then we'll go back into the matrix menu, and we will go to edit again, and we want to tell the calculator to memorize the numbers inside of the matrix B. So we will edit matrix B by either clicking on 2 or going down with the arrow, then clicking enter. The matrix size first, it's a 2 by 2 matrix. So automatically it removes some entries, and there's some leftover numbers that we don't care for. We will just write on top of them. So we will put 5, then 6, then 7, then 8. And there we go. That's it. So the matrix B is now memorized in my calculator. What I'll do next is I'll just go ahead and quit this whole thing. So back on the main screen, I want to tell the calculator to multiply the matrices A and B for me. So what do? I go second matrix, but this time we won't move left or right. We will just put 1 for the matrix A times, then again, we enter the matrix menu, and then put 2 for matrix B. And then just click enter, and there you go. So 19, 22, 43, and 50. And by doing this, I just discovered that I think I had 33 instead of 43. So let me go back to my PDF form over here and change this to be 43 instead of 33. So you can see why it's useful to always check your answers. Now, suppose I want to find the product of B times A. So what if I put B first and multiply that by A? So as we mentioned before, the multiplication of matrices is not commutative. So first of all, in this particular problem, matrix A and matrix B were both 2 by 2 matrices, so I can multiply B times A. But the order is different, so the answer I'm expecting to see is going to be different because multiplication is not commutative. So once I click enter, you see that the numbers are completely different than the original A times B. So this is why when you're multiplying matrices, you have to be super, super careful about the order that you put the numbers in and the order that you put the matrices in, especially if you're doing this with a calculator. So A times B is different than B times A, as we can see from the screen of our calculator. Okay, and the instructions that I mentioned a few minutes ago are here on this page. So if you want to pause the video for a second and copy them or take a screenshot or whatever, in this paragraph, I'm explaining how to put the numbers in and how to multiply matrices, so on and so forth. Okay, so the last thing we're going to do is just practice some more of these products. So in example 9, we have a matrix A and a matrix B, and in part 1, we are expected to find the product of A times B. So I'll do this by hand first, then we'll confirm with our calculator. So first things first, can I even find an answer for A times B? This matrix has 2 rows and 3 columns, so this is a 2 by 3 matrix. And the B matrix has 1, 2, 3 rows and 2 columns. So the inner numbers are identical, they're equal, so therefore we can find the product of A times B. So I'm going to go ahead and write down the A times B. The matrix A is negative 1, 2, and 3, with 4, 0, 5 in the second row. And I'm expected to multiply this with the matrix 5, negative 1, then negative 4, 0, then 2, and 3. Okay, so we said this is a 2 by 3 matrix. We said this is a 3 by 2 matrix. So the answer will be a 2 by 2 matrix. So I know that when I find A times B, it's going to be some matrix missing 4 numbers. And we have to find those 4 numbers to be completely done with this whole problem. So the matrix AB will be a 2 by 2 matrix. Okay, so how do I find those missing numbers? So depending on which one of the missing numbers you want to find, you have to do a different thing. So let's say I want this first one in the first row and the first column. Because it's in the first row and first column, we take the first row on the first matrix and the first column on the first matrix, and we multiply the numbers. So with my little pencil, I'm going to just barely write negative 1, then 2, then 3, and multiply all those numbers. So negative 1 is going to get multiplied with 5. Then I'm going to multiply 2 with negative 4. Then I'm going to multiply 3 and 2. So that's what's going to go in my first entry. And I'm done, so I'm just going to erase everything at this point. So let's say I want this guy down here in the second row, first column. Because it's the second row, first column, I'll grab the second row on the first matrix with the first column of the other matrix. I'll write the numbers 4, 0, and 5 in my pencil, and I'll just go ahead and multiply 5 with 4, then add to it 0 times negative 4, then add to it 2 and 5. And in the same way, we proceed to fill the rest of the matrix. So I want the first row, second column next. First row and second column. So we, again, have to multiply a bunch of numbers and add them up. So the numbers that we have to multiply are negative 1 with negative 1, 2 with 0, and 3 with 3. So negative 1 gets multiplied with negative 1, then 2 and 0 get multiplied, then 3 and 3 get multiplied, and we just add up everything at the end. And finally, if I want the last entry of the AB matrix, what is it going to consist of? The last entry is going to be found in the column 2, row 2. So because it's in row 2, I grab the row 2 of the first matrix. Because it's in column 2, I grab the second column of the other matrix, and I'm supposed to multiply those numbers, 4, 0, 5 with negative 1, 0, 3. So 4 times negative 1 and 0 times 0 and 5 times 3. Once you multiply all of them, you will combine them, you will add them up to see what the final result is. So that's the setup, and now it's just a matter of multiplying and adding correctly all the numbers. So I'll go ahead and do that next. So what is the product of A times B going to be? Let me shift some things around so we can have some space to put everything in. And the answer is negative 7, 10, 30, and 11. So as you can see, this is a 2 by 2 matrix, and that's it. So let's confirm that this is the solution by putting all the numbers into our TI calculator and seeing if we get the same result as well. So in my TI calculator, I have to enter the matrix menu first, then I'll go to edit the matrix A. My matrix A had 2 rows and 3 columns, so I'm going to type in 2, enter, 3, enter. And next, I need to put in all the different values. The first entry in row 1, column 1 was a negative 1, so tiny minus sign, then 1. Then I have 2 and 3. And just keep clicking the numbers in, followed by an enter to go to the next row or the next column. So 4, 0, and 5. So that's my matrix A, just looking at it to confirm that it's correct. Sounds good. We quit, and we go back into the matrix menu again one more time. We go to edit, and this time we're going to edit matrix B, which had 3 rows, but only 2 columns. And again, the numbers are 5, -1, followed by -4 and 0, followed by 2 and 3. And we will leave this whole thing. We will just quit the whole matrix menu. And now I want to tell my calculator to multiply the two matrices A times B. So I go second matrix to enter the matrix menu. I click 1 on my keyboard for the name of A to appear. Then I multiply by the matrix B. So again, second matrix. And I click 2 on my keyboard, and that puts the B matrix next. So A times B is equal to -7, 10, 30, and 11, just like we said previously, right, when we did it over here by hand. So although the process is more difficult by hand, it's not impossible to do it. As you saw, we're able to do it no problem. So for part 2, it says to find the product of B times A. So they want the B to be first and A to go second. So remember, the matrix B is a matrix that had size 3 by 2, and the matrix the matrix A had size 2 by 3. So the numbers on the inside are the same, they are equal, so therefore we should be able to find the answer. And the answer, in fact, will be a 3 by 3 matrix. So it's going to be a matrix with 9 missing numbers in it. And, it's not impossible to do it by hand, but it's going to be a lot more challenging, a lot more time consuming, let's say. So instead of doing it by hand this time, I'm going to actually use the fact that I just typed everything into my calculator, and I'll just get the result directly from my calculator screen. So let's see, here's my calculator. I want B to be first, so I'm just going to clear my screen first, then click second matrix, put the matrix B, then multiply it with the matrix A. And there's the answer right on the screen. Let me do just one entry by hand so we can see how this is done. So I'm going to write -1 for the, 5, -1, then -4, then 0, and 2, 3. That's the matrix B. And I'll just do one quick entry, but I won't do all of them because we already know the answer. So -1, 2, and 3, then 4, 0, and 5. So suppose I want the entry in the second row, second column. So that's the one I'm searching for. So I want this one that would have gone over here. Second row, second column. How can I find it by itself without looking for everything else? Well, because it is found in the second row, second column, I'll have to take the second row of the first matrix and the second column of the other matrix and multiply the entries there, then add them up. So it will be like a -4 written down in pencil, then 0 there. And so I'll multiply -4 with the 2, then I'll add 0 times 0 to it. And the total will be -8. And that's exactly what we saw in the calculator screen. We had a -8 right in the center of the matrix. So that's how you would go about finding the answer to the product. But at this moment in time, I'm not going to do more of these things. I'm just going to copy the answer directly from my calculator screen. I had -9, then 10, then 10 again. I had 4, the -8 that I just found, and I had -12. Then I had 10, 4, and 21 as my final answer. And so you can see this matrix in this problem has a side 3 by 3. And we predicted that would be the case because originally the matrices were 3 by 2 and 2 by 3. So we expected the answer to be a 3 by 3 matrix. So as I mentioned, this is not always doable, and it's not always true that A times B will be the same as B times A. And I think this example will be a perfect example of that. We have two matrices, M and N. In this instant, M is a matrix that has 3 rows and 2 columns, and matrix N has 2 rows and 2 columns. So if I want to find the product of M times N, would that be possible? Well, let's see. I look at the inner numbers, 2 and 2. These guys are equal, so M times N is possible. As a matter of fact, it will be a 3 by 2 matrix. So I can expect that this guy will be a 3 by 2 matrix. And what will the answer be for this problem? So it's going to have 3 rows and 2 columns, basically. Well, let's do a few of them. We're not going to do the whole thing. We can use our calculator. But let's say I want the first row, first column entry. I grab the first row and the first column, and I multiply the numbers. So I'm just going to think 5 is going to get multiplied with 4, because I'll put a 5 here and a 1 there. And then the 3 will get multiplied with the 1. Then I need to add all the answers up. So 5 times 4 and 3 times 1, I believe that's going to be 23. So suppose I want the entry directly below it. Well, that entry is in the second row, first column. So therefore, I have to grab the second row and first column, multiply the numbers with one another. So 0 and 4 get multiplied because there will be a 0 here and a 3 there. Then 3 and 3 will get multiplied. Then I have to combine or add the solutions. So 0 times 4 plus 3 times 3 will be a 9. And we continue the same way. So if we want, for example, the entry that would be adjacent to it, so the one that would be right here. This is the entry in the second row, first column. So I would grab second row and, sorry, it's the entry in the second row, second column. So I would grab the second row, second column. I would write 0 and 3 right there, and I would multiply 0 with -2, 0 with 3, and I would combine the solutions, and the answer is going to be obviously 0. So that's how you would continue and proceed forward in terms of finding all of the entries of all the matrix. But since we have a few of them, let's continue the rest of the problem with our calculator. So I'm going to give you a moment here to pause the video and put all these numbers into your calculator and multiply M and N with each other and see if we get the same result, you and I. Pause here, please. So you may have noticed right off the bat that in your matrix menu, if you try to edit and put M and N, there aren't enough letters here. So it's not a problem. We can reuse the original letters. So in my case, I'm going to put the numbers that belong to M in the matrix A. So instead of thinking of M, I'm going to think A. And the numbers of N, I'll put them in another matrix called B, for example. And I already typed all the numbers in. So for my matrix A, the numbers are 5, 1, 0, 3, -2, -5. And I did the same for the matrix B. As you can see, there's 4, -2, 3, and 0. And all I have to do now is multiply M and N. In other terms, I got to multiply the matrix A with the matrix B. And we will see 23, -10, 9, 0, -23, 4. So -23 is first, then we have the 10, and so on and so forth. We already have some of the entries, so all I have to do is fill out the rest of them. So 3 were found by hand, but 3 other entries were found with the calculator. And on an exam or on the homework or a quiz, you are allowed to use any method of your preference. So if you like the calculator option, you can use it all the time. If you prefer to do this by hand, you can do it by hand as well. Just know that if you forget your calculator, you can't borrow a calculator from somebody else, and you can't use your cell phone. So you need to know how to do this by hand. So now for the second problem, we have to find the product of n times m. So let's see, is that doable? Is that possible? So n goes first, then m. Remember, n is the matrix with size 2 by 2, and m is the matrix with size 3 by 2. And unfortunately, these numbers here are not equal. So what does that mean? That means it is not possible to find the product of n first, followed by m afterwards. And if you try to do this with your calculator, by the way, the calculator should freak out and give you some kind of an error. So let's see that. So remember, for me, n and m are a and b, but it doesn't matter. Let's see if I put b first and try to multiply it with the A matrix, then my calculator should be smart enough to know that something is wrong, and it will say dimension mismatch. So it tells me something is wrong, something is off, I'm not able to perform the product. And that's again because of the numbers inside of the middle. They are not equal, so it is not possible to find n times n. So you would say no solution or no answer. The last thing we'll do in this section is talk about an application of matrices. So this is kind of similar to what we started the section with. We have a table, we have some data in the table, and we need to rewrite it and manipulate it and do some work with it. So in this case, it says in example 11, the playground company manufactures 3 types of swings and at 2 different manufacturing plants, one in San Diego, one in Los Angeles. The table below shows how many of each type of swing set was produced at each plant during 2023. So how do I interpret this number, for example, the 1,000? This means that we produced 1,000 swing sets in San Diego in 2023. And we produced 1,200 or 1,200 basic sets in Los Angeles, and so on and so forth for deluxe and premium. So part 1 says write a 2 by 3 matrix to represent the information, and we're going to call this matrix matrix M. So matrix M for this problem will be just simply 1,000 followed by 800 followed by 950, and the second row is going to be 1,200 followed by 600 followed by 900. So that's my matrix M, and the size of this matrix is 2 by 3 because it is containing 2 rows, which are these, and 3 columns, which are these columns. Okay, so that is part 1. It's very straightforward. There's not much to do. Remember, the 2 by 3 is called the order or the size or the dimension of the matrix. You might hear any of those words depending on your instructor or depending on what class you're taking or what your instructor prefers to use for that particular course. So that's the matrix M. And now for part 2, it says that the manufacturer anticipates that in the coming years, they will increase production of each type of swing at each plant by 20%. They want us to find a matrix N that represents the amount of increase in production. So what are they saying? They're saying that there's a new matrix N, which is 20% of the production type that we already have. So what do we have to do? We have to basically multiply 20% of M to get the matrix N. So this represents the amount of increase in the production. We don't like 20% in math, so I'm going to write 0.02 instead of 20%. And I just have to do a scalar multiplication. I got to multiply the matrix M, which already has the numbers 1,000, 800, 950, and 1,200, 600, and 900. I just have to multiply all that matrix with 0.02 to get the matrix N. The size will be the same. Remember, this is scalar multiplication, so it's pretty straightforward. And if you do the multiplication, you'll discover that the numbers are going to be 200 because 0.02 times 1,000 is 200. And then 0.02 times 800 will be 150. And 0.02 times the 950 will be 190, and so on and so forth. So the next one is 240, then 120, and finally 180. So this matrix N is also a 2 by 3 matrix, and it represents just the amount of increase in production in the manufacturing plants in San Diego and LA for the 3 types of swings, the basic, deluxe, and so on and so forth. So next in part 3, they want me to find M plus N. So what's this going to be? This represents the number of swings that the playground company will manufacture after the 20% increase. So how much the total is going to be after the increase has happened, considering that we already had 1,800 and so on and so forth. So in this case, I'm just going to take matrix AM, which was 1,800, 950, and then 1,200, 600, and 900, and add it to the matrix N, which we just found ourselves, which had the number 200, 150, 190, and 240, 120, 180. So adding up the numbers in the two matrices, first of all, is it legal to add the numbers? Yes, because the two matrices both have size 2 by 3. The original one had size 2 by 3, and the new one that we created, it was a scalar product of the original one, so they're both 2 by 3 matrices. All we got to do is add the numbers, and again, we add the 1000 with the 200, we add the 800 with the 150, and so on and so forth until we get to the end. And so that's the end of that part 3 of this problem. I'm just going to shrink it down a little bit so that it's not taking up or hiding the next question. So again, what does this represent? What do these values represent? These values represent the number of swing sets that the playground company will manufacture after the 20% increase in production has taken place. So for part 4, we are given another table that represents the cost to manufacture each type of swing set in 2023. So the cost to make one set, regardless of whether it's in LA or San Diego, is $110 for the basic set, and $150 for the deluxe set, and so on, $200 for the premium set. And what they want me to do is write this as a matrix. So this is matrix C, representing the costs. The numbers are 110, 150, and 200. What's the size of this matrix? This matrix has 3 rows, but only 1 column. So 3 rows and 1 column. Therefore, it's a 3 by 1 matrix. So this is a 3 by 1, kind of a strange matrix. When it's got 1 column only, we usually call it a column matrix instead of a regular matrix. We add the word column next to it just because it automatically means that we only have 1 column in this matrix. Okay, so finally, we need to multiply the matrices M and C and see what kind of answer we get and describe the answer and give, some meaning to the numbers that we will have. And to multiply the matrices, I'll go ahead and use the TI calculator as usual. I'm going to put matrix M as a matrix A and matrix C as matrix B in my calculator, and then perform the product of M times C. So we want to multiply M times C, where M was the matrix 1000, 800, 950, followed by 1200, 600, and 900. We want to multiply that matrix with the matrix C, which consists of the 110, 150, and 200. First of all, can we even multiply these two matrices? Let's see. The matrix M is a 2 by 3 matrix. It's got 2 rows but 3 columns. And the matrix C has 3 rows and 1 column. The inner numbers are equal. So therefore, yes, we can multiply. And as a matter of fact, the answer is going to be a 2 by 1 matrix. These numbers on the outside is what we get. So 2 by 1, that means it's a matrix with 2 rows and only 1 column. Now, if you forget your calculator and you want to do this by hand, how would you go about doing it? You would take your 1000 and you multiply it with the 110, then you would multiply the 800 with the 150, then you would multiply the 950 with the 200, add up all the answers, and those all go in the first entry on top. Since this is going to be a lot of work, let's go ahead and use the TI calculator to speed up the process a little bit. I just entered the numbers into my calculator, but just to confirm, we can go and click on matrix A. That's going to be the one referring to the numbers that were in matrix M for us in paper. So it's a 2 by 3 matrix and it's got all the numbers. If you want to navigate, if you make a mistake and you want to change a number specifically, you can use your arrows to move around the matrix and go to the one you want to change and just type in a new number on top of it. That's how you would make the change basically. But that's my matrix M, and the matrix N is going to be matrix 2 for me, which contains the numbers 110, 150, 200, and I've confirmed that all the numbers are correct. So let's go ahead and multiply matrix M by matrix N. And again, I don't have the letters M and N on my calculator, so I'm just going to use A and B to perform the product. And there we see there's 420,000, and the second row is 402,000. Okay, so that's the answer for the product part, and they want me to describe, and they're asking what information does this product of the two matrices give us. And in this case, what this gives us is it says that the total manufacturing cost at the San Diego plant is 420,000, but the total cost of the manufacturing in LA is $402,000. So these are dollar amounts because we're multiplying the cost with the numbers in the production. And again, this number represents the costs in San Diego, whereas this number represents the costs of manufacturing in LA.